Hello everyone, welcome to this video, to the second video in the decorator pattern. So we left the previous one when I showed you the code that I gave you as a pre-version of the code, and I asked you to try to implement the decorator pattern following the class diagram that I gave you. So let's have a look at how we get that done. So before that, we're going to take a look at that class diagram that I showed you before. So I know in my implementation of this, I'm going to need a car decorator class that implements the car interface, and I will need two sub decorators or two concrete decorators that are going to extend the car decorator class. So let's take a look at how we do that. Well, first of all, I need to have my classes. So I'm going to create my new instance. I'm going to create my new class that I'm going to call car decorator. Now this car decorator, as we know, needs to implement the car interface. So at the moment I implement the car interface, the unimplemented method has to be implemented. So I will inherit the assemble method that is defined in the car interface. So let's take a look at what other class I need. I need my two concrete decorators. So I am going to create a sport decorator, say sport car. And that sport car will extend the car decorator. And I will also have a luxury car, and the luxury car is also going to extend the car decorator. So at this point, we've managed to have the structure of the code. So let's take a look at how how we flesh this out a little bit. Well, the first thing is if we go back to the class diagram that I gave you, one of the things that I need to define is that my decorator needs to have an instance of the target interface. So in this case, my target interface is the car, so I need to have an instance of that. So of course, I know I won't be able to instantiate the interface itself, but I would be able to instantiate any subclass of the interface class. So I can say car, and then if I need to have it, then I will define that as a requirement in the constructor. So I can say public car decorator. And then in here, I'm going to define that I need to get a car, and I will say this.car is equals to car. Now, it makes sense that if I need to have an assemble method, well, I can call the assemble method from the instance that I already have. So I can say for my decorator, the assemble method is going to be this.car.assemble. So what I'm doing is just calling in a kind of a chain. Now, what problem am I having here now? Well, as soon as I added a constructor to the car decorator, my sport car that extends the car decorator is telling me, hey, you need to have the constructor. So I'm adding the constructor there to say, well, if you're creating an instance of the sport car, you need to give me a car that I can decorate. Remember, the decorator will change behavior. We'll see that in action in a second. But this is where the magic is going to start happening. So if I have a sport car in here, the only behavior that I can modify, and remember, the decorator class is going to, the decorator pattern is going to modify the behavior of a particular class at running time. So the only behavior that I can modify in this particular case is the assemble method, because I don't have any other method in my car class. So what I'm going to do is I'm going to override my public void assemble method. So in here, we can change the behavior of the assemble method as we want. Now, what I'm going to do just to illustrate the point is that I'm going to call the original method. I'm going to say this is a car assemble, but I'm also going to add some sort of customization because this is the sport car. So I'm going to say whatever the original car has plus the decorating option. So in this case, I'm going to say adding sport features. There you go. So before yeah, let's do exactly the same thing for the luxury car. So the luxury car needs to implement the constructor, and I'll just modify the assembled car. It's just that instead of saying adding sport features, I will say adding luxury features in this case. Luxury features, brilliant. Now, this is my decorator pattern. Let's see this pattern in action. So I can create a car C2 that is of the type, let's say, sport. Now, as soon as I do that, of course, I'm missing the import because the sport car class lives in another class. But one of the things that it's going to tell me is, hey, I need a car. Because remember, the sport car is a decorator. It's also a car because it implements the car interface, but it's also a decorator. So it needs to receive an instance. It needs to receive a car to decorate. So in this case, I'm going to decorate the original C1 object. Now, I'm not going to call the method as C1 assemble, but what I'm going to do is I'm going to call, I'm going to say C2 that assemble. And let's see what happens when I run this. So when I run it, yes, I get the features of the basic car, but the sport feature have been added to that method. So the behavior of the object has changed. Now let's do exactly the same thing. Let's say a car C3 is equals to a new luxury car. And this time let's decorate C2 because remember, I need to decorate somebody. And of course I'm missing the import in there. So this time I'm not gonna call this guy, but I'm going to say C3.assemble. So when I run this, notice that my original car that I was C1 it has the basic car, but it also has the sport feature and it also has the luxury features. So the beauty of this method is that at running time, if I want to create any combinations of them, I don't need to create more and more classes. Suppose I have 4 classes and infinite combinations of those 4 classes. Well, I can do that very easily with the decorator pattern. Now, something that sometimes some people do, again, you don't have to do it, but some people actually do, is that they make the car decorator an abstract class. If you make this an abstract class, that just means that you won't be able to decorate to create an instance of the car decorator class. That might be a good option. Abstract class decorator, and then everything else still works the same because in your main you're only instantiating instances of the subclasses, the sport class and the car class, which are concrete classes. So again, making the car decorator an abstract would be a good idea, but it's not necessarily mandatory. Brilliant. Now that we've seen these, I wonder if you've seen this before. Let's take a look at this code that we have in here. I have a basic car that then I'm changing modifying the behavior of the basic car, but I need to pass an object in there. And then if I pass a different object, the behavior is different completely. Well, we've seen that before. Let's take a look at this. Okay, so we've seen that before in the buffer reader. So your buffer reader class receives a new input stream reader system therein, and that's when you're reading from the keyboard, but it receives a new file reader when you're reading from a text file. So what the pattern that has been implemented in here is the decorator pattern. my decorator class is the buffer reader. My target class is the buffer reader, and my decorator is the input stream reader. So I am changing the behavior of the buffer reader every time I pass a new instance or a different instance. So let's take a look at the class structure of these. The file reader extends input stream reader, and the input stream reader extends reader. So it's no coincidence that the buffer reader constructors receives a reader in the it receives a reader in as a parameter. So because I receive a reader, I can receive either an input stream reader, or I can also receive a file reader. Anything that is a reader will be passing. And of course, depending on the one that I pass, the behavior will be modified. The behavior would be different. So that's the design pattern that has been implemented in this case. Now, some implications. The decorator pattern is very, very helpful using when you want to do runtime modification of abilities of some objects. Of course, that makes your coding a lot more flexible and a lot more robust, because if you need to add more behaviors or more functions, you just add the new decorator classes. That's perfectly doable. And some of the disadvantages is that the code can go quite big and quite confusing, because for each new feature you need to add a new decorator. So that might be a little bit confusing. But as we saw already, this is used in other structures such as the file reader or the buffer reader. Well, guys, thank you very much for watching. I hope you enjoyed the video, and I'll see you in the next one.